Hello everyone. In this new TopChem2 tutorial, I will show you how to compute conceptual DFT descriptors. First, we will calculate the global CDFT descriptors. Then, I will show you how to display the dual descriptor. The first step is to select the wave function file, here in WFX format. For this example, I choose the ethylene molecule. First, check the wave function. Normally, you should see some virtual orbitals, with at least one orbital corresponding to the LUMO. Here, we have 5 virtual orbitals. We begin with the global CDFT descriptors. Simply click on the suitable button, and the values are displayed directly within the frontier molecular orbital approximation. We can see, for example, the ionization potential, the chemical potential, and the electrophilicity index. You can also check the HOMO and LUMO energies. Now, let us calculate the dual descriptor. This is very simple. In the reactivity descriptors section, select the dual descriptor. You can see that the DLD function is automatically selected. You can also check the command line. Now, simply click on the Run button. You can see that the LUMO is detected. And the cube and compressed CubeS files are produced. First, let us look at the population file. Select the dld.pop file and click on View Pop. Here, we find again the values of the global conceptual DFT descriptors. We also find the dual descriptor cube and CubeS files. As usual, the first visualization option is to use VMD. Select the VMD file. This is the file ending with _dd.vmd, and click on Run VMD. OK, the visualization is now ready. In red, we have the nucleophilic regions, whereas in blue, we have the electrophilic regions. Of course, you can modify the isosurface value for the nucleophilic regions in red. And for the electrophilic regions in blue. OK. The second visualization option is to use the TopChem2 molecular viewer. To do this, select the file ending with _dd.xyz. And click on View Output Structure. The molecular structure is now displayed. Now, you can load the cube file to display the isosurfaces of the dual descriptor. For example, select the compressed DD CubeS file. The first isosurface corresponds to the positive values of the dual descriptor. Adjust the ISO value using the corresponding slider. By default, positive values are displayed in blue. We can also display the negative isosurface, which is not selected by default. The negative isosurface is controlled by the Isosurface 2 slider. Adjust the value from large negative values on the left toward 0 on the right. We can now see the nucleophilic regions. Now, let us switch to full screen mode. OK. See you soon for the next tutorial. Bye.